Welcome back to Chem 104, and we're still in Chapter 1. This is the second section. This will be pretty quick, I think. I'm just going to talk a little bit about measurements, and then in the third part we're going to talk about significant figures. So we talked a little bit about states of matter and how we classified those in the first part. And so now we just need to talk about, we're going to be making measurements in chemistry. And so we need to know that there are two components of a measurement. The first is the number, and the second is the unit. And a number is meaningless without a unit. It's just 5, okay? But if it's 5 grams, that tells us what that means, okay? And so make sure when you're doing calculations, I know a lot of you are going to be nurses, dosage, you want to make sure that you know what your units are, because 325 milligrams is a whole lot different from 325 pounds or kilograms. So you want to make sure that you're using the correct units when you're doing that. All right, so each type of measurement has a base unit in the metric system. Okay, so if you have a gram, okay, that's what we're using as our base unit. The length, that's mass, we call it. Okay, so we've weighed something out, we know how many grams it is, but mass is really what we're looking at. And length is the meter, okay, and that's a little m, just like grams is a little g. The liter is the volume, and it's a capital L. And then time, yay, one that we're familiar with, is the second. All right, and so those are our basic metric units that we're going to be using. And the nice part about using the metric system is that we can take that then and we can use it in multiples of 10 and figure out exactly how many we have by the prefix that we use. So the prefixes are going to be, as I said, in powers of 10. If it's smaller or larger, it depends on what prefix we use. Now, in chemistry, in general chemistry especially, mainly what we're going to be using are the kilo and the centa and the milli, and sometimes the micro. So those are the main ones we use. A kilo, that's the big one that we use, okay? And the kilo means that it's 10 to the third or 1,000 times bigger than, 1,000 times bigger than whatever we're talking about. Okay, does that make sense? So if it's a gram, it's going to take 1,000 of those to make 1 kilogram. So 1,000 grams equals 1 kilogram. Now that's the big one. Now mega, you may see in some of your homework problems. Giga, that's 10 to the 6th, 10 to the 9th. But primarily kilo is what we see in big, because in chemistry we don't use a lot of big things, okay? Not when we're just studying chemistry, maybe in industry or something, and definitely in the human body. Okay, so then we're going to look at small things, which is what we're going to encounter more in the medical field. Centa is 1/100th, okay? So it takes 100 centigrams to equal 1 gram. That's what that means. Or if there are 10 to the minus 2, or 1/100th of grams is equal to 1 centigram. You can think about it either way. I usually like to use whole numbers, so you'll see that I use those. Okay? All right, a milli is going to be 10 to the minus 3, which is 1/1000th. So it takes 1,000 milligrams to equal 1 gram. And micro is 10 to the minus 6, and so it's going to take 1,000,000 micrograms. Notice that kind of funny U with the leg on it, is equal to 1 gram. So it's all base 10. These are our small ones. This is our big one. Remember, you can use a 1 3x5 index card on each test, okay, and the tests are by chapter, so you could have one for this chapter test, and then you could have one for the chapter 2 test when you take those first tests. And so these are things you can write down on there if you want. All right, so measuring length. The base unit of length is the meter, okay, the meter. So if I have 1,000 meters, that means I could also just say I have 1 kilometer, or we usually say kilometer. All right, and so that would be 1 km, kilometer, is equal to 1,000 meters. A millimeter is equal to 0.001, or 10 to the minus 3 meters. 1 millimeter equals 0.001 meter. Now remember how I like to do it is, the other way to say that is, there are 1,000 millimeters in 1 meter. And that way I don't have to do those 10 to the minus whatevers. A centimeter, 1/100th of a meter, 1 centimeter is equal to 0.01, or 10 to the minus 2 meters. The other way to say that one is, there are 100 centimeters, just like there's 100 cents in a dollar, 100 centimeters in 1 meter. Okay, and so that's our base length. All right, so mass. You hear people use these interchangeably. Mass is actually how much matter you have, as opposed to weight, which is how much the force of gravity pulls on that. And they're related, but the reason that we kind of draw this difference is because if you are on the Earth, which has a certain gravitational pull, as opposed to being on the moon, which has less of a gravitational pull, your mass would always be the same, but your weight would be different. Okay, because weight is just how much gravity is. That's why if you've ever seen those old movies of the astronauts on the moon and they're like skipping way high and all that, that's because they don't have much weight to them. They still have the same amount of matter, so they still have the same mass, but they have less weight when they're on the moon. Kind of appeals to me. I don't know about you. All right, so the base unit of mass is the gram. And again, it's just the same. You apply that kilo the same way we did with the meters. 1 kilogram is 1,000 grams, and 1,000 milligrams is 1 gram. Okay? So 1,000 milligrams is 1 gram, because it takes 1,000 of those to be 1. But the kilo is the big one. Milli is our small one. So it's 1,000th of a gram, all right, if you're a milligram, and it's 1,000 if you're a kilogram. The base unit for volume, the base unit for volume is the liter, all right, and in the liter, you can have a kiloliter, not very often. Okay, that would be 1,000 liters. Usually we look at small numbers. A milliliter is going to be 0.001 liters, or remember the other way of saying that is, there are 1,000 milliliters. It takes that many to make 1 liter. So volume, if you have a solid, something that you can measure, sometimes we use, dice like you throw in games, and you have, see how I can do this. I'm not a very good drawer. You'll see that. Okay, that's my cube. Okay, and so if you want to get the volume of a cube, you say the length times the height times the width. All right, length times width. And if you're doing that in centimeters, since you're doing 1 centimeter times 1 centimeter times 1 centimeter, you end up with 1 centimeter cubed, because 1 times 1 times 1, that's 1 cubed, okay, but it's still 1. But centimeter, you have to use the units when you're multiplying something. You also are multiplying the units together. And so in chemistry, 1 milliliter is the same as 1 cubic centimeter, and the old naming for that was 1 cc in medical. Okay, so 1 cc is a milliliter, also, and that stands actually for a cubic centimeter. All right, so we live in America, and in America we still use the English system of measurement. And so because of that, we have to do a lot of conversions. And so there are conversion tables that we have. All right, and so I do allow you to use a conversion table on your tests. And if you look on Blackboard, you'll see where that is, and it says things that you can use for your test. Okay, so instead of a foot, they use meters. All right, and so if we're looking at length here, there are several things that we could do to convert between length in English and metric. Okay, so you just kind of have to find one that you can remember. The one I always remember is that there are 2.54 centimeters and 1 inch. Now, once I get to that, okay, so if it's given to me in English system and I want to convert that to the metric system, I know that there's 2.54 centimeters in an inch. And I also know if I need it in feet, then I can convert it once I get to inches to feet, because I know there's 12 inches in a foot. For mass, okay, now I'm a licensed practical nurse in addition to being having a doctorate, and so I also use 1 kilogram equals 2.20 pounds, because that is what we use in medical to go between kilograms and pounds when we're trying to do dosages. Okay, some people like to do the 454 grams in a pound. That's fine. Whatever one you can remember is fine. Just remember, though, you've got to remember how many ounces are in a pound, and sometimes you have to know how many pints are in a quart and how many quarts are in a gallon, and things like that when we get down here to volume. All right, so in volume, they don't even have the one that I use. The easiest one is probably that 1 liter is equal to 1.06 quarts, if you know that there are, 4 quarts in a gallon, and so then you can kind of figure that out. So mine is that there are 3.875 liters in 1 gallon. That's usually the one that I use to go across. But you can use any of these that you want to. There's always more than one conversion that you could use. Just remember, most people I find don't remember what the English conversions are because we don't really think about them that much. But quart, just like a quarter of something, you have 4 cups in a quart, 2 pints in a quart, okay, 32 ounces in a quart, and then there are 4 quarts in a gallon. So you got to remember the English system as well. All right, so this is where you can stop me and think about what these are, and we've talked about these, so you should be able to answer these. So put me on pause and see if you can answer these questions, and then come back and we'll see how you did. Okay, all right, we're back. So the first question was, what term is used for 1,000th of a second? Remember, 1,000th means small. All right, so 1,000th of a second is going to be a millisecond. And the way we abbreviate that is ms. What term is used for 0.01 grams? Again, that's smaller than a gram, right? So it's going to have a th on the end of it. So that's 2 places, so that's 100th of a gram, right? And we would call that a what? Centigram, or not a second, a gram, CG. Which quantity is larger, 5 kilometers or 5 centimeters? Remember, the kilo is the big one. Kilo is the big one. Sometimes I say, like if you ever watch any of those cop shows, I'm addicted to investigative discovery and stuff. When they make a drug bust, if it's a really good one, they've gotten kilos of stuff, and they're these big, packages of things. And so a kilo is big. So a kilometer is also big. A centa is what? Small. Okay, so it's going to be the smaller of the two. So our 5 kilometer is going to be the larger of those two choices. All right, how many nanometers are in 1 meter? You may have to look back at your chart there, but 1 nanometer, okay, is a 10 to the minus 9, because I'm not going to write all those zeros, I'm sorry. Okay, so 10 to the minus 9 is a nanometer. That's how many meters are in 1 nanometer, okay? 10 to the minus 9 meters in 1 nanometer. But what the question is asking is how many nanometers are there in 1 meter? It's easy, easy. If you want to know that, there are 10 to the 9 nanometers in 1 meter. Okay? That work? All right, if you need to go back and kind of brush up on that a little bit, that's fine. Otherwise, we're going to look at significant figures here in a minute. What a significant figure is an exact number that if you have an exact number from counting objects, you're going to have an exact number is everything significant that you've counted. And so in the next portion, we're going to talk all about those significant figures, okay? So stay with me. It's going to be fun, I promise. All right.